In this video, I want to talk about a Lewis symbol for Lewis structures. The Lewis symbol is just the symbol that's used on the periodic table. Carbon, for example, would be C for carbon. And this symbol represents the nucleus plus the core electrons, or the inner electrons. Carbon on the periodic table is right here, and it has atomic number 6. It's in the second period, and it's in group 4. Right here. This tells us a lot of information. So with the atomic number 6, it tells us that it has 6 protons, 6 neutrons, and 6 electrons. So the nucleus would be in the center, and it would have 6 protons and 6 neutrons. Since it was in the second period, it will have 2 shells. So in the first shell, it would hold 2 electrons, and the second shell would hold 4 electrons. The 4 electrons would be the valence electrons, and the core electrons would be all the electrons that are not the valence electrons. So all the electrons that are not the outermost shell are the core electrons. So it would have 2 core electrons. So that would be what the symbol C would represent. What is important is the valence electrons, or the outermost shell, which are these electrons right here. And we represent those by dots around the symbol. So it has 4 valence electrons. So we put 4 dots around symbol C. If we wanted to make a Lewis symbol for oxygen, right here, we can see that it is in group 6, so it'll have 6 valence electrons, and it's in period 2, so it will have 2 shells, and the atomic number is 8. So the symbol would be O for oxygen, and this would equal nucleus, or the protons and neutrons, plus the core electrons, which are all the electrons that are not valence electrons. So the nucleus would have 8 protons and 8 neutrons. The first shell would have 2 electrons, and it was in group 6, so it would have 6 valence electrons in the outer shell. When we represent the valence electrons on a Lewis symbol, we just put a dot on 4 corners, and we first put 1 dot on each of the 4 corners, and then we can double up the dots. I'm just going to put 1 right here. What is important is simply the valence electrons. All we have to do for that, for chlorine, is go to the group number. We can see that it's in group 7A, so we know that it's got 7 valence electrons. So on the periodic table, the symbol for chlorine is Cl. It has 7 valence electrons, so we'll put dots around the symbol. First we'll start with 1 dot, then we'll start doubling them up. So we have 1, 2, 3, 4, 5, 6, 7. And that's it. We already know it's in period 3, it's in group 7, so period 3 says that it's going to have 3 shells. We only need the outermost shell, the valence electrons, so it's going to have 2 shells of core electrons, plus the nucleus will be represented by the symbol Cl. It's in group 7, so it's going to have 7 dots around the symbol, and this is the important information that we need. The point of Lewis theory is to get to a point of stability, which would be 8 valence electrons. So all we need to know is how many valence electrons are on it. I'm just going to fire a few of them off. So if we wanted silica, it's in group 4A, so it's going to have 4 valence electrons. The symbol is Si, and so we put 4 dots around the symbol. If we wanted sodium, it's in group 1A, so it gets 1 valence electron. It's going to have 1 dot. If we wanted sulfur, it's in group 6A, so the symbol for sulfur is S, and it has 6 valence electrons. We start with 1 electron on each of the 4 corners, and we start doubling them up. I like to make them balance, so instead of putting it here, which would be the very next one, I'll go ahead and kind of balance it out like that. So to sum this up, the symbol is the periodic symbol, and the valence electrons are the number of dots that go around the symbol. We can just get the valence electrons from the group number. Something like this makes very quick work of what we just went through.